Hi guys, in this specific video we're going to look at the concept of isotopes, and this basically are going to be variant forms of specific elements that we have looked at across the periodic table. So some elements are going to display unique characteristics insofar as the mass number and the atomic number is concerned, and they were looked at in our introductory part of the representation of elements. We had looked at various constituents of the nucleus and the of course the orbiting electrons in an atom. So in a sense, if we are going to have these specific numbers, especially for the atomic numbers being the same, and then the atomic weight is going to vary, these element symbols which are similar are going to be referred to as isotopes. For instance, we can say that the carbon-12, carbon-13, and carbon-14 are going to be isotopes of carbon, and they're going to display various properties and characteristics, as we're going to see later. Therefore, we can give an element that have several values of the atomic weight, and since the number of the neutrons are going to be the same, and this is going to be, of course, referred to as the isotopes of those specific elements. So the isotopes of elements can be represented using various ways, and there are some, of course, elements that we're going to see in the periodic table displaying these specific characteristics of having isotopes. For instance, the element of uranium, hydrogen, and other elements that we're going to see later are going to display this as a specific property. Now, the nucleus constituents of an element as well can be displayed in forms of a symbol. We had said that this is a general representation of an element whereby an isotope of an element can be represented using various atomic weight numbers in this specific case. Now, in this, in a sense, we're going to see that there's a slight variation of the number of neutrons which are going to be shown in the nucleus, and therefore we can be able to represent the neutron using this specific number for N01 represented as that, and this is a proton that is going to be represented using this specific notation that I've given on this specific board. So therefore, if we look at this specific case, and we're going to see this E being represented as such. This is a representation of what we refer to as an electron, and therefore it's going to have a zero number in this specific case. We had talked about the concept of electron mass and said that the electron mass is relatively lower in terms of value or quantity as compared to the neutrons and protons, which are having almost the same atomic mass unit. So in this specific case, then therefore we are going to assume that this is going to have a zero value at this specific point. So therefore, if we try to look at the lower part, it's going to represent this specific size. So for a combination of a proton and electron, or the laws of attraction, these are going to cancel out and have that equilibrium. Therefore, the electron is going to be attracted to the proton, which has a positive charge, as we said before. So in this specific part of my display, I've given a combination of numbers which are going to form what we call the atomic weight and the mass numbers, and this basically are going to be the number of protons and neutrons which are found in the nucleus, which have been given basically in a figurative way. So this for tritium, and it's going to be given as such. And we have, as I've said, the isotopes for deuterium, hydrogen, and tritium, which can be illustrated as such. So for carbon, we're going to see that it's going to contain 6 protons and neutrons that are going to form carbon-14 isotope, and the number of protons are going to be 6, as I've indicated. And for a neutral atom, it's going to contain the same number of electrons, so that they can have a balance of a charge, which I had mentioned in my previous statement. So I hope this is going to assist us try to understand various aspects that we have learned, especially in the representation of an atom, and various application areas that we're going to see, especially concerning the concept of radioactivity, which basically is a nucleus or a mass transformation process that occurs in the nucleus. So that is it for now, guys. Bye, God bless. We'll catch us in our next video.